In this video, we'll talk about finding the derivative of a function at a point. We'll also review our previous derivative rules in this video. So suppose we want to find the derivative of f of x equals x squared times cosine of x at the point x equals pi over 2. So we're simply going to take our first derivative and then plug in the value x equals pi over 2. So f prime of x, there's a product here, x squared times cosine of x, so we need the product rule. This is the first times the derivative of the second. The derivative of cosine of x is negative sine x, plus the second, that's cosine of x, times the derivative of the first times cosine of, times 2x. We can rewrite that if we wish. We could rewrite that as negative x squared times sine of x plus 2x cosine of x. Now we just want to evaluate that at x equals pi over 2. So that's negative pi over 2 squared times sine of pi over 2 plus 2 times pi over 2 times cosine of pi over 2. As a reminder, sine starts at 0 and goes up, and sine of pi over 2 is 1. So sine of pi over 2 is 1, whereas cosine starts at 1 and goes down, and cosine of pi over 2 is 0. So this is cosine and this is sine. So basically we don't need to worry about this term at all because it's just 0, so all of that just goes away. What we have remaining is f prime of pi over 2 is equal to negative pi over 2 squared, so that's pi squared over 4, times sine of pi over 2, that's just 1, and so we're left with negative pi squared over 4. And if we wish, we can write that as its decimal approximation, so that's approximately negative 2.467. It's an irrational number. The decimal continues and never repeats or terminates, so that's just an approximation. Or we can leave it in this form. Either way is good. So to find the derivative at a point, all we need to do is find the derivative like usual and then plug in the point of interest. So here are some examples to try out yourself. G of x is e to the 5x over x squared minus 3x at x equals 1. H of x is 4x to the 7th plus 2x to 2 to the x at x equals negative 2. Y equals 3x squared minus 7 over 2x plus 5 all to the third power at x equals 0. And f of x equals x squared natural log of 5 minus 3x at x equals 1. So try each of those out and then we'll go through them. Okay, for g of x, we need a quotient rule here. G prime of x is low, that's x squared minus 3x, d high, derivative of the top, e to the 5x. So that's a chain rule because 5x is a function inside that e to the something function. So times 5e to the 5x minus high d low e to the 5x times the derivative of the bottom 2x minus 3 is the derivative of the bottom, all divided by x squared minus 3x. So we could do some, simplifying and whatever if we wish for g prime of x, or we can just leave it as it is and just plug in x equals 1. Let's do that. G prime of 1 is equal to 1 squared, that's 1, minus 3 times 1, times 5 e to the 5 times 1, that's 5, minus e to the 5 times 2 times 1, 2, minus 3, that's a negative 1, and then it's all divided by 1 squared, 1 minus a negative 3, so I'll write that out. 1 minus a negative 3, that's plus 3. So then we can continue to calculate that value. All right, so this is 1 minus 3, that's 2, times 5 is 10 e to the 5th, minus a negative, so plus e to the 5th, divided by 4. And so finally that is, oh, sorry, that was a 1 minus 3, so that's a negative 10 e to the fifth. And that gives us negative 10 e to the fifth plus e to the fifth is negative 9 e to the fifth divided by 4. We can leave it in that form if we wish, or we could plug that value into a calculator to get an approximation. This ends up being negative 333.93 is an approximation, rounded to 2 decimal places for that value. For our next function, we've got h of x equals 4x to the 7th plus 2 to the x. H prime of x then is, using just the power rule here, 4 times 7 is 28, x to the 6th, plus derivative of 2 to the x is natural log of 2 times 2 to the x. And now all we need to do is plug in. So h prime of negative 2 is 28 times negative 2 to the 6th power plus natural log of 2 times 2 to the negative 2. And so that simplifies to 28 times 2 to the 6th is 64. 2 to the negative 2 to the 6th is also 64, plus natural log of 2 divided by 2 squared divided by 4. And if we grab a calculator and simplify that, we'll get 1792.17. Okay, for this one, y prime, we're going to need to do both a chain rule, and then inside that we'll end up needing a quotient rule. So the outside function is something to the 3rd power, so we've got 3, leave the inside alone, 3x squared minus 7 all over 2x plus 5, and decrease the power by 1, and then multiply by the derivative of the inside. So here we'll need to use a quotient. So it's the bottom times the derivative of the top, 6x is the derivative of 3x squared, minus derivative of 7 is 0, minus the top, 3x squared minus 7, times the derivative of the bottom, that's just 2 is the derivative of the bottom, all over the bottom squared, 2x plus 5 squared. So let's see, would it be useful to simplify some stuff? We could, if we were especially looking at it for different values of x, but since we're thinking for x equals 0, maybe a lot of stuff will just go away for us. So y prime is 3 times 0 minus 7 divided by 2 times 0 plus 5 squared times 2x plus 5 times 6x. So since it's times 6 times 0, that just goes away. Minus 3 times 0 minus 7 times 2, all divided by 2 times 0 plus 5 squared. So that's 5 squared is 25. So now just to calculate a little bit more, we've got 3 times 49 is negative 7 squared times negative, so positive 7 times 2 is 14, all divided by 25 times 25. This 5 is squared, and then we've still got that 25, and then we can calculate this out as well, and we'll end up with 3.29. So none of these are super nice, beautiful numbers, but that's fine. Last one, f of x equals x squared times the natural log of 5 minus 3x at x equals 1. So f prime of x is, we need a product rule first of all. It's x squared times natural log of 5 minus 3x. So first times the derivative of the second. Now we'll need a chain rule when we're thinking about the derivative of natural log of a function of a function. Derivative of natural log of something is 1 over that something times the derivative of the inside. Derivative of 5 minus 3x is just negative 3. So that was the first times the derivative of the second, plus the second natural log of 5 minus 3x times the derivative of the first. Derivative of x squared is 2x. And so then we're looking at plugging in the value x equals 1. So let's rewrite this just a little bit more nicely. This is negative 3x squared divided by 5 minus 3x plus 2x times the natural log of 5 minus 3x. So plugging in f prime of 1, that's going to give us negative 3 times 1 squared, negative 3 over 5 minus 3, that's 2, plus 2 times 1, so just 2, times the natural log of 5 minus 3, the natural log of 2. And so we've got f prime of 1 is negative 1.5 plus 2 times the natural log of 2. That's approximately 0.69, but let's throw it into a calculator and get a more value. So when we throw this all into a calculator, we end up with negative 0.114 as our decimal approximation.